myself, Dr. Urvashi Mishra. Here we have to discuss second order differential equation with constant coefficient. To solve this equation by reduce it to normal form. Then first we discuss about the procedure. Let the given equation be d2y upon dx square plus p dy upon dx plus qy is equal to r is the standard form. Then first we want to know that whether we have applied this method or not. For this we calculate I, which is q minus half dp upon dx minus p square by 4. Then whether I is equal to constant or constant upon x square, then we apply this method. Now we consider the procedure. First let the given equation is then we calculate I. Suppose I is constant, which is a square. Then we the part of the complementary function, which is u is equal to e raised to minus half integral over p dx. Let the solution of equation 1 is y is equal to vu, where u is this and we have to find by reduce it to normal form. Then find dy upon dx or d2y upon dx square. Putting these values in our equation 1. Equation 1 is converted to like this. Then solve this equation and find the value of b. Then the solution, but it will be the solution of equation 2. But our problem to find the solution of equation 1, which is y is equal to vu. Then putting the value of v and u, we find y. Now, next we consider 2 or 3 problems. First problem, we have to consider here d2y upon dx square minus 2 tan x dy upon dx 5y is equal to e raised to x sec x. Here p is equal to 2 raised to 10x, q is equal to 5y and r is equal to this. First we calculate I, which is q minus half dp upon dx minus p square upon 4. Then that is p dash p square by 4. Calculate this, that will be 6. Then we apply this method. Then first we have to find part of complementary function, which is u is equal to e raised to minus half integral over p dx. P is this, then putting these values integral over this, and we have to find u is equal to sec x. Now let solution of given equation is y is equal to vu, where u we have find it sec x. Then now putting these values in equation 1, the equation 1 is reduced it to normal form d2v upon dx square plus iv is equal to r upon u. Putting the value of I, R and U, we have this equation. This is a simple equation, and then we easily solve this by finding CF and PI. First we have to find CF for this auxiliary equation. Solve it, then CF is equal to C1 cos root 6x plus C2 sin root 6x. Particular integral EX upon D square plus 6. Calculate this PI. Then solution of equation 2, V is equal to CF plus PI. But it is the solution of equation 2. But our solution is y is equal to v. Then put these values v here. This will be the complete solution of equation 1. Now we consider another problem. d2y upon dx square minus 4x dy upon dx plus 4x square minus 1y is equal to minus 3 e raised to x square sin x. Then compare with the standard form. It is p, it is q, it is r, and find I, which is same as q minus half dp upon dx minus p square by 4. Putting these values and solve it, it will be 1 constant. Therefore, we have to find part of complementary function u is equal to e raised to minus half integral over p dx. Putting the value of p, it will be e raised to x square. Let solution of this equation 1 will be given that y is equal to vu. Vu is equal to e raised to x square. Let equation 1 can be reduced to its normal form. d2v upon dx square plus iv is equal to r upon u. Putting the value of I, putting the value of R and U, we have equation d2v upon dx square plus v is equal to this. Then we have equation d2v upon dx square. Equation 1 is reduced to d2 upon dx square plus v is equal to minus 3 sin x. To solve this, we have to find CF and PI. CF for this auxiliary equation, m square plus 1 is equal to 0, m is equal to plus minus I. Therefore, CF is equal to C1 cos x plus C2 sin x. Pi is equal to 1 upon d square plus 1, 3 sin x. Then coefficient of x is 1, then put d square is equal to minus a square. It will be minus 4 plus 1. Then 3 and 3 cancel, answer is sin x. Therefore, solution of equation 2, v is equal to cf plus pi. Cf plus pi. But we have the solution of equation 1, which is y is equal to uv. V is this, u we have to find earlier, therefore this will be the complete solution of equation 1. Now we consider another problem. d2y upon dx square plus 1 upon x raised to 1 by 3 dy upon dx plus 1 upon 4 x raised to 2 by 3 minus 1 upon 6 x raised to 4 by 3 minus 6 upon x square y is equal to 0. Compare with standard form, it is P, Q and R. Then first we calculate I. Q minus half dp upon dx minus p square upon. Putting these values, it will be minus 6 upon x square. Then this problem is the type of constant upon x square. Now we have to find part of CF. U is equal to minus half integral over p dx. P is this, where substitute P. Solve this, answer e raised to minus 3 by 4 x raised to 2 by 3. Now the complete solution of equation 1 is y is equal to vu. Put the value of u here and v. Then u is what? E raised to minus 3 by 4. Minus is already there and minus, then it will be your minus. Let equation 1 can be reduces to d2y upon dx square plus iv is equal to r upon. But r is 0, therefore right hand side be 0. Then if we have to solve this equation, then it will be the form of x square d2v upon dx square minus 6v is equal to 0. This is the type of homogeneous equation. And so that we have to put here x raised to ez or z is equal to log x. Therefore, x square d2v upon dx square is d minus 1 into b, where d is equal to d by dz. Then putting these values in this equation, we have this type of equation. This is the equation number 3. And solve this equation, find CF and PI. CF is m square minus f auxiliary equation. M is minus 2 minus 3. Therefore, CF is equal to C1 e raised to minus 2z plus C2 e raised to 3z. Here it is the important part. Here CF is the form of z, because in equation, our equation can be converted to d2v upon dz square. Therefore, solution in terms of z. Particular integral is 0 because right hand side should be 0. The solution of equation 1 is given by y is equal to v into u. V is that c1 e raised to minus x, because x is equal up to z is equal to x. Therefore, e raised to z is equal to x, so that c1 x raised to minus 2 c2 x cube. And u we already find. Putting these values, this gives the final solution of equation 1. Then we have to apply this method and solve different types of the problem by reducing it to normal.